Today we are learning about divisibility. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will find by which digits a number is divisible. Factors, multiples, and divisibility. You can use these divisibility rules to determine if a number is divisible by another number. This is a shortcut and saves you some time rather than having to work out each problem. So, a whole number is divisible by 2 if the ones digit is 0, 2, 4, 6, or 8, basically if it's an even number. So some examples in the right-hand column are 2, 8, 24, 96, and 300. A number is divisible by 3 if the sum of the digits of the number is divisible by 3. So if we take 144, we add the digits together. 1 plus 4 is 9. 9 is divisible by 3, so 144 is also divisible by 3. For 4, a number is divisible by 4 if the last two digits of the number are divisible by 4. So if we look at the example of 124, the last two digits are 24. So 24 divided by 4 is 6, which we know means 124 is evenly divisible by 4. A number is divisible by 5 if the ones digit is 0 or 5. So some examples to the right are 205, 300, 1005, 270. A number is divisible by 6 if the number is divisible by both 2 and 3. So if it meets the 2 and 3 divisibility rules, both of them, it's also divisible by 6. So our example here is 522. It's divisible by 2 because the ones digit is a 2. It's divisible by 3 because 5 plus 2 plus 2 is 9. And we know 9 is divisible by 3. So since 522 is divisible by 2 and 3, it's also divisible by 6. A whole number is divisible by 9 if the sum of the digits of the number is divisible by 9. So it's the same test we used for the 3, it's just a bigger number. So for 3,123 in our example, 3 plus 1 plus 2 plus 3 equals 9. 9 is divisible by 9. It equals 1. So we know that 3,123 is evenly divisible by 9. Finally, a whole number is divisible by 10 if the ones digit is 0. So 20, 40, 150, 2,570 are all examples of that. Next, we're going to tell whether each number is divisible by 2, 3, 4, 5, 6, 9, or 10. For 25, we know it does not end in an even number. So we know it's not divisible by 2. When we look to see if it's divisible by 3, we add 2 plus 5, which is 7. 7 is not divisible by 3, so neither is 25. For 4, use the last two digits of the number. In this case, we only have two digits, so we know 4 doesn't go into 25. Then for 5, we know it ends in a 5, so we know it's going to be divisible by 5. Next, we check 6. It's already failed the 2 and the 3 test, so we know it's not divisible by 6. We look at 9. We already know the digits add up to 7, which is not divisible by 9. And we know we can't divide it by 10 because it doesn't end in a 0. For 32, we're going to go through the same steps. So first, we check to see if it's divisible by 2. And since it ends in a 2, we know it is. Then we check for 3. So we're going to add the digits together. 3 plus 2 is 5, not divisible by 3. We look and see if it's divisible by 4. We only have two digits in the number. We know 4 goes into 32 8 times evenly. So it's also divisible by 4. For 5, we know it doesn't end in a 5 or a 0, so it's not divisible by 5. It's already failed the 3 test, so we know it's not divisible by 6. When we added the digits together, we got 5, which is not divisible by 9. And it doesn't end in a 0, so it's not divisible by 10. For number 3, we have 124. We know it ends in an even number, so we know it's divisible by 2. For 3, we add the digits together. 1 plus 2 is 3, plus 4 is 7, not divisible by 3. For 4, we look at the last two digits, which are 24, which we know is divisible by 4. So 124 is also divisible by 4. We know it's not divisible by 5 because it doesn't end in a 5 or a 0. We know it's not divisible by 6 because it already failed the 3 test. We know it's not divisible by 9 because the digits only add up to 7. And it doesn't end in a 0, so we know it's not divisible by 10. For 4 through 7, we need to tell whether the first number is a multiple of the second. Basically, what that's asking us to do is decide if the first number is divisible by the second. So for problem 4, we have 45. It doesn't end in a 0, 2, 4, 6, or 8, so we know it's not divisible by 2. For number 5, we have 155, and we're trying to decide if it's divisible by 5. We know because it ends in a 5 that it is. For problem 6, we have 240, and we need to know if it's divisible by 6, which means we need to test it with both the 2 and the 3 divisibility rules. We know because it ends in a 0, it is divisible by 2. To decide if it's divisible by 3, we're going to add the 2 plus the 4, which is 6, plus 0, which is 6. 6 is divisible by 3, so it meets both criteria, and it's also divisible by 6. For number 7, we have 320. We have to decide if it's divisible by 10. And in this case, because it ends in a 0, it is divisible by 10. So we're going to write yes for that one as well. For 8, number sense, name 3 factors of 40. Factors are numbers that when you multiply them together will equal the number that you're looking for, in this case 40. So we know some of the factors of 40 include 1 and 40, 2 and 20, 4 and 10, 5 and 8, and at that point we know it's not divisible by 6 or by 7, so we have all the factors. You need to write down at least 3 of them. For 9 and 10, we need to use the information they give us here. There are 100 members in the U.S. Senate. There are 435 members in the U.S. House of Representatives. Is the total number of U.S. senators divisible by 2, 3, 4, 5, 6, 9, or 10? So we're going to take 100, and we know it's divisible by 2 because it ends in a 0. We know it's not divisible by 3 because 1 plus 0 is 1, and 1 is not divisible by 3. For 4, it asks us to look at the last 2 digits. Those happen to be 2 zeros, so this is a tricky one. We do know 4 goes into 125 times, so it does divide evenly. For 5, we know it ends in a 0, so it is divisible by 5. We know it's not divisible by 6 because it already failed the 3 test. So we're going to check for 9, and 1 plus 0 is 1 when we add the digits together. So it's not divisible by 9. So finally we check for 10. Does it end in a 0? Yes, it's divisible by 10. Finally, for problem 10, could the members of the U.S. House of Representatives be evenly divided into committees with 3 members each, 5 members each, or 8 members on each? So if we look, we're going to add the digits together to test for the 3 first. So 4 plus 3 is 7, plus 5 is 12. 12 is divisible by 3, so yes, we could divide them evenly into committees with 3 members each. Next, we have to check 5 members each. We know it ends in a 5, so yes, it's also divisible by 5. Finally, we need to check and see if it's divisible evenly by 8 members each. And in this case, 8 is not going to go in evenly. But because there's not a specific test, we do actually have to show the division on this one. So as you can see from the work off to the right, 8 does not divide evenly into 435. Please make sure you have all the work written down, and then glue this paper in your math notebook.